All right, let's see how we did here. Again, this is review. We're starting a new chapter today, and we will be reviewing chapter 5 as we go along, because when we take our next test, which is to chapter 7, we're skipping chapter 6. We take our chapter 7 test, half of it's going to be chapter 7, half of it will be chapter 5. And that'll be, as always, that chapter 5 portion will count as your retake on this one that you took on Tuesday. Again, those grades are in there. If you're not happy with your chapter 5 grade, no biggie. We just need to make sure we nail this stuff down before we take that next test. Whatever your grade is for chapter 5 right now, I can change it to 100 if you can show me that you know this on the next one. Okay. Chapter 4 grade is locked in at this point. You've already had 2 shots at that. I think about half of you did better on the chapter 4 portion Tuesday than you did the first time around. That's awesome. That means you're showing improvement. So I was able to go back and raise your original chapter 4 grade to match your new grade. That's fantastic. So all right, let's do this. So this is from chapter 5, first term, second term, third term. So I'm just going to fill out my table by copying those values down. Now, I don't know my 5th term. I don't know my 0th term. We're going to need those. In order to do that, though, we need to figure out what our pattern is. What did you all find for your pattern here? We adding, subtracting, multiplying, adding how much? 1.5. And is that consistent each time we go to the next one? We're adding 1.5. So if I want my 5th term, then could I just take 10 and add 1.5 onto it and get 11.5? Awesome. So congratulations if you're able to find that 11.5. If I wanted to go backwards to get my 0th term, what's the opposite of adding 1.5? Minus 1.5. And what is 5.5 minus 1.5? 4 or 3, 4? I think it's 4. I think it's 4. Cool. All right, we have all the pieces we need to write our equation. As a reminder, your equations for these, well, actually it depends on whether it's geometric or arithmetic. Which one is this? Arithmetic, because we're adding the same each time. Arithmetic equations look like this. And in this spot, we put our change. And in this spot, we put our start, or 0th term. So our change was 1.5. And we started our 0th term at 4. So I need a plus 4 there. So 1.5n plus 4 for the equation. How many people were able to come up with 1.5n plus 4? Nice. Well done. All right, let me catch up with you on the second one. I'm going to copy down my 1st, 2nd, 3rd, 4th term. So 1st term, 2nd term, 3rd term, 4th term. So when I first looked at this problem this morning, I thought that I was adding to get to the next one. I thought I was doing plus 12, but when I tried to do plus 12 here, that didn't work for me. So it's not adding. This one actually ends up being geometric, so we're multiplying. Did anybody figure out what we're multiplying by? What'd you find? 1.5? And that times 1.5 was consistent. That got us through to the next one also. How did you come up with 1.5? Was it just a lucky guess? Okay, yeah. You knew it was somewhere between 1 and 2, and you just kind of guessed some numbers. Was anybody able to use division to come up with that 1.5? What did you divide to come up with 1.5? Awesome. So you remember that when you're looking for that multiplier, you can just pick 2 numbers and divide them. You always want to do the second one divided by the first one. So I'm going to make myself a little note here. This is my little thought bubble. If I were looking for that 1.5 and I wasn't sure, I would go 36 divided by 24 to get 1.5. And I'm putting this in a little thought bubble because I wouldn't normally write this down if I were doing a problem, but that's what I would be thinking to get that 1.5. So if you weren't sure how to get that, or if you just guessed, I'd recommend that you make a little note on how you can do it, because it may end up, you may end up with a problem where the multiplier is like 1.268, and you're not going to guess that one very quickly, right? So you want to make sure you know how to divide to get it also. So make yourself a note of how you could divide. You pick any 2 numbers and then you do the second one divided by the first. And then I love that you actually checked it with another pair to make sure that it was also coming out to be 1.5, and you found that that was consistent. Awesome. So once we know it's times 1.5, then we can figure out what this is. 81 times 1.5. Let's see. 80 times 1.5 is 120, and then 1.5 ones is 1.5. So 121.5. Nice. And then the 0th, I'm not going to find so easily. It's 16. Awesome. Thank you, guys. All right, and this is a geometric sequence because we're multiplying. So we need an equation that looks like this. And in these equations, the start value goes in the front and your multiplier goes inside the parentheses. So our start value was 16. Our multiplier was 1.5. So the equation we need to write is 16 times 1.5 to the n. How many people were able to get that equation? Awesome. Well done. Well done. Does anybody have any questions about this? This is just a quick review from last chapter. One of the reasons I wanted to talk about this is because what we're getting into today with exponential functions is going to look a lot like these geometric sequences that we did in the last chapter. So if you're feeling pretty confident about geometric sequences, you're going to be able to use that to get yourself up to speed on exponential functions very quickly. If you struggled a little bit on geometric sequences last chapter, that's okay, because as we learn about exponential functions, it's going to help you really understand those geometric things. So if you can make those connections, it's going to help you with both on both ends. Okay, questions before we move on? All right, so this next part's going to be a little chaotic because we need computers. So I need you to get your laptops out. Now, if you do not have your laptop, or if it needs to be plugged in, then you're going to need to solve that problem. All right, the solution would be move to a place in the room where you can plug in. There's plugs along both walls. There is a long extension cord over here with a power strip that you can pull towards the front row. If you don't have a laptop full stop, like if you don't have it at all, then you're going to need to find somebody who does and partner up with them and sit next to them. Okay. So please get your laptops out, get them fired up. It's going to take us a minute or so to get this going. So all right, so get yourself to a web browser. And we are looking to get to desmos.com. So you can just type in desmos.com. You're going to see a blue button up at the top that says graphing calculator. Go ahead and click on that. And it's going to take a couple of minutes till everybody's ready to go here. So feel free while you're waiting to just mess around. You can put some equations in, try graphing some stuff. Try something like, try this graph for me. Go y equals 2 sine, that's sin x. Isn't that a neat looking graph? While we're waiting for everybody to get caught up, play around with that graph a little bit. You could change that 2 to something else. It's sine, S-I-N-E is the full spelling of it. And you're going to learn all about it when you get to Algebra 2. And so while we are waiting for everybody to kind of get their computers started and everything, let's go ahead and take some notes. And I am going to put these right into my packet. I would highly recommend this. We're going to be talking about these new kind of functions today called exponential functions. And I want us to make some quick notes about some basic exponential functions. So put this into your packet someplace where you've got some space for that extra notes. We're gonna make some quick notes on basic exponential functions. And for today, we're going to be focusing on exponential functions that have an equation that look like this. Y equals, I'm going to call it b to the x power. And this b right here is just going to be a number. I'm sure everybody remembers y equals mx plus b, right? When we write an equation in that format, don't we usually put a number in for m and we put a number in for b? Right, m is the slope and b is the y-intercept. So this is the same idea. We're going to put a number in here. So we can change this b, but the y and the x are going to stay. So our goal today is to relate what these equations and these graphs and how they go together. Okay. So this is really important. I need everybody's attention for a moment. If you are kind of dealing with computer stuff, pause on that for a moment and look up here because I want to show you where we're headed today. Okay. Here's our ultimate goal. Can I get everybody to look up at the screen, please? At the end of class, I'm going to give you a little exit ticket. It's like a quiz, but it's not for a grade. Okay. I'm going to show you what it looks like right now so that you know what you're looking for today. So you see how these equations here are all in that same format that we just wrote in our notes? Y equals some number and then to the x power. Pay attention, please. Y equals some number to the x power, right? See how they're all in that same format? Well, these equations are going to have graphs that look like this. And at the end of today, I want you to be able to look at these graphs and figure out which one of these equations would give you graph A, which equation would give you graph B, and which equation would give you graph C. So our ultimate goal today is for you to be able to look at an equation and predict what the graph is going to look like based off of the equation. Or for you to look at a graph and predict what the equation is going to look like. So at the end of class today, I'm going to give you a little slip of paper like this, and you're going to fill it out and you're going to turn it in. And this is not for a grade, but this is our overall goal is for you to be able to look at this and figure out which one of these graphs is going to, which one of these equations would be A, B, and C. Okay, so that's where we're headed. We want to be able to relate an equation to a graph. Okay, and to do this, we're going to play around a little bit with Desmos. So let me switch back over to Desmos here. Lots of buttons. So I'm deleting this. I'm going to go ahead and put my my Desmos in high contrast mode. So if you click on the little wrench icon there, the bigger A just makes it easier for you guys to see on the screen. So it may look a little bit different from yours, but that's fine. By the way, if you end up touching your screen and you accidentally zoom in and you get kind of zoomed in or zoomed out like that, you'll see a little house icon appear over here. If you click on that house icon, it'll take you back to the default zoom. All right, can I get you guys all to, are you all in Desmos? Does anybody need a moment to get in Desmos? You won't see it until you zoom in. So if you try zooming in, then you'll see it pop up and that'll take you back. So the house icon, if you don't see it, it's because you haven't zoomed in. You're already on the standard. So, all right. Can I get you guys all to click over there where it says number 1? We're going to type in an equation. Y equals parentheses. Y equals parentheses. And then I need a number to put in for that B value that you put in your, you want to do 4? All right. Thank you for volunteering. 4. We'll all do 4 to start. End your parentheses. And then we need to get an exponent of x on this. Do you guys know how to do an exponent? An exponent. So on your keyboard, there's a little caret symbol. If you look at the numbers across the top of your keyboard, you see how the number 6 has a little caret symbol. If you do Shift 6, that'll send your cursor up to your exponent and you can put an X in there. I think there's another way to do exponents also. If you click on this little keyboard at the bottom of Desmos, the one that says A with an exponent of B would also get you an exponent too. So you should be seeing a graph that looks just like mine. Are your graphs all blue also, or do you have different colors? Yours is green. Nice. You got purple? Do you guys know how to change the color on Desmos? Anybody interested? A little bit. All right. You see how it's got the little squiggle next to your equation? If you click that squiggle, it'll turn it off and on. If you click and hold on that squiggle, it'll allow you to change your color. All right. And I want to show you something else, okay? One more thing real quick. Could I get everybody to go underneath that equation and type in parentheses 1, 2 in parentheses? You should end up seeing a dot appear on your graph. Type that into your second line. In the third line, go ahead and type in parentheses -1, 2. And in the fourth one, type in 3, 3. All right. And now it's time for the challenge. I'm going to pause for a moment, make sure everybody's got those 3 points graphed. Are we good? Give me the universal sign for I need another minute if you need another minute. Okay. So we're doing 1, 2, -1, 2, and 3, 3. Got it? Yeah, you do. All right, you're there. Awesome. Okay, so here's a challenge. We can put any number we want, well, maybe not any number, but we can change this 4 into other numbers. And my challenge for you is to figure out what do you need to change that 4 into to make these 3 graphs. Okay, so I'm going to give you guys 5 or 10 minutes to play around with this. And I would like for you to create me 3 graphs. I don't care what color they are, that would resemble this. And when you, in each of your graphs is going to look like, each of your equations is going to look like this. You just have to figure out what number goes in here so that you get all 3 of those graphs on your screen. Okay, so that's your challenge. So take that 4 that we had in there and try changing it to something else. See if you can get it to match. And we're trying to get, each of your graphs is going to go through one of those points that we put on there. All right, play around with that. Feel free to spy on your neighbors. Feel free to turn around and look at, ask some people behind you, ask me for some hints. Let me know if you think you've got all 3 of those on your graph at the same time, and I'll check it for you. We'll come back together and chat about this in a little bit. So it looks like a lot of us are pretty successful on hitting those 3 points. Well done on that. We're gonna talk about it in just a sec here, okay? So I know some of us have questions and we're going to get those answered. You'll have to trust me on this. Can I get you all to go back to your notes? And I want to sketch this situation. Now, I don't have graph paper here, but that's okay. I can draw some relatively straight lines. And I'm just going to put a few tick marks. 1, 2, 3, 1, 2, 3, 1, 2, 3. And I'd like us to sketch these 3 graphs. For those of you who were able to get all 3 of them, can you look at your 3 graphs and tell me, what do all of those 3 graphs have in common? They all go through one particular point. What's the one point that they all have in common? 1, I need 2 numbers for a point though. What, comma, what? 0, 1. 0, 1. Is it on the y-axis? Is it on the y-axis? The y-axis is the one that goes up and down. Is it on the y-axis? So that would be 0, 1. Are you talking about this point right here? Yep. Have you drawn this on your paper? You're going to want to do that. All right. So they all go through this point right here. And then one of our points went through 1, 2. So I'm going to draw, or one of our graphs went through 1, 2. So I'm going to draw a point at there. And that graph looked like this. And one of our graphs went through 3, 3. 3, 3 would be here. And that graph also went through here, but then it curved up through that point. And then one of our graphs was kind of going the other way. It went through 1 or -1, 2. And it curved downwards like this. and it went through that point, which I didn't draw very well, but good enough for my notes. So if you guys all graph those in your notes, let's label these. I'm going to label, I don't know, I'm going to go A, B, and C. And I would like for us to go ahead and write some equations. So could I get a volunteer to read me your equation that you put into Desmos to get it to match up with A? Anybody want to volunteer for A? Chris, you probably got closer than anybody else on this. Do you want to give me your value that you used for A? Okay, I'm gonna round that off a little bit. That was 1.4422. Okay, 1.4422. If you were working on A, you were probably somewhere in that neighborhood, like 1.4. I saw some 1.45s. Hold that thought for just a second. A was this one right here. Oh, I didn't. All right, so 1.45, that's really close to this, isn't it? Cool. Do you want to tell me again what you did for B? Because I think you gave me the answer for B a second ago. You did 2. So if you didn't get B to match up, go ahead and try putting 2 in your parentheses there. And then for C was kind of the weird one that was going downhill instead of uphill. What did you guys end up putting in for your base for C? What did you put in? 0.5. Did anybody do that as a fraction? Did anybody do it as 1/2? That would work. 1/2 is the same as 0.5, isn't it? 0.5. Yep. Great. All right. Now, I want you to play around a little bit more in Desmos because there is an important rule that happens with B. So B is going to give you, there's a rule that tells us whether our graph is going to be increasing or decreasing. Which of these graphs are increasing? A and B are both increasing, right? And C is decreasing. Shh, please don't shout out answers. Thank you. So see if you can find me a rule. What kind of values for B cause our graphs to be increasing? And what kind of values cause our graph to be decreasing? Okay, so play around in Desmos a little bit more. You can just change one of these and see if you can make another one that would also be decreasing that has a different number than 0.5. Okay, talk it over with your table partner, talk it over with the people around you. See if you can figure out what is the rule to determine whether your graph's going to be increasing or decreasing. When I say it's increasing, it's going to look like this, and when it's decreasing, it's going to look like this. Talk it over. We'll take a couple of minutes and then we'll come back and we'll pull our minds together and see if we can come up with a good rule here. All right, let's come back together here. Can somebody give me a rule for if your B value is this type of number, it's always going to be increasing? If it's positive, okay. Any positive number is going to give you an increasing graph? Not anyone, because 0.5 gave you a decreasing. So above 1. So can you guys confirm that if you put any number in the parentheses that's bigger than 1, you're going to have an increasing graph? I just want to test this really quickly. We know it's true if your number is something like 1.4 or if it's 2. Let me get back to my Desmos here. What if my number was something like just a tiny bit bigger than 1? Give me a number that's just a little tiny bit bigger than 1. 1.1. 1.1. So is that still increasing? It is. It's not increasing very fast, but it's definitely increasing still. So can we stick with that? The graph is going to be increasing if B is bigger than 1. So sorry, let me get back to my dot camera. I just wrote that, but it's not on the screen. So B, the graph is going to be increasing if B is bigger than 1. So then what happens to B if our graph is decreasing? Bigger than 1 means it's increasing. What has to be true to make it decreasing? Smaller than 1? Give me an example. 0.9. 0.9 is just a tiny bit smaller than 1. I'm going to try this on my Desmos real quick and just make sure you're right. If I change it to something just slightly smaller than 1, 0.9, it is decreasing. Not very fast, but it is decreasing. Now, can I make it anything less than 1? Any number less than 1 is going to make it decreasing, yes or no? Yes? Okay, let me try -2. I broke it. I broke it, right? I'm not even seeing, if I get rid of everything, when I put a -2, it's just giving me a bunch of dots. So we need to modify this. It's not just less than 1. What are we not allowed to put in for B? We can't put negatives in. We cannot put negatives in. So the graph is going to be decreasing if B is less than 1. But not negative. Now, did anybody try putting 0 in for B? You did? What happened to the graph when you put 0 in for B? If you didn't try it yet, go ahead and try it right now. That also gives you a wacky graph. That's kind of weird, isn't it? Is that increasing or decreasing? The answer is no. Neither, right? It's flat. It's flat, and it's weird because not only is it flat, but there's no negative portion to it. Did anybody try putting 1 in for B? If you haven't tried 1 yet, try that. What does 1 give you? It's another flat one, but this one's flat and it goes in both directions, both left and right. That's kind of weird, isn't it? All right, so we're going to modify our rule here. Back to this. I wish there was a shortcut button for that. So the graph is decreasing if B is less than 1, but more than 0. It's like 0.5 is going to be a decreasing graph. 0.9 is going to be a decreasing graph. 0.1 is going to be a decreasing graph. But if I put a 0 in here, that's not going to work. That breaks it. If I put a negative number in here, that doesn't work. In fact, let's make ourselves a note here that B can't be negative. Although somebody figured out you can put a negative on the X and that makes some weird things happen. We'll talk about that later on. All right. There's one more thing I want to talk to you guys about, and then we're getting pretty close to time for our little quiz. So let me go back to my Desmos. You guys still in Desmos? If you're not, could you get back into it and graph for me the one that's had 0.5 inside the parentheses? Turn everything else off. You can just click the little icon next to it to turn things off and on. Turn everything else off so you're just looking at 0.5 to the X power. It should be decreasing, right? Because we're doing 0.5 and that's less than 1, but bigger than 0. Let's get that phone away, please. Put it in your bag, please. Thank you. Okay, here's my question for you guys. Look up here. This is really important. Excuse me. When I look at this tail over here on the right-hand side, Do you think it's ever going to get down to the x-axis? Is it ever actually going to touch the x-axis here? Yes or no? What do you think? And if it does, how far do we have to go before it actually touches? So if I were to zoom this in, if I were to come out here and zoom in, is this thing actually touching the x-axis right here? Yes or no? No, it's really close, isn't it? It's at 0.00011, but it's not touching. If I move it over a little bit, move it over a lot bit. Come on. This thing doesn't want to work with me today. If I move it over a little bit, it's even closer. But is it ever going to get down to 0? Now, Desmos will eventually round it off and tell you that it does go down to 0, but it doesn't. In reality, it never does. So these graphs are going to get ridiculously close to 0, but they never actually get there. Do you remember how I told you guys you can never actually walk out of this classroom? You remember that? There's this paradox of motion that says, if I want to walk from where I'm standing and go through that door, first I have to go half of the distance, right? And then from there, I'm going to have to go half of the remaining distance. And from there, I got to go half the remaining distance. And no matter how close you get, you're always going to have to cross halfway in between, which means you're going to infinitely be stuck going half and half of that and half of that and half of that. And so math kind of tells us we're never going to get there. And that's why we invented calculus, by the way, so that we can actually get out of doors. But that's the same thing that's happening here. It's going to get closer and closer and closer and closer, but it's never going to get there. So this concept has a name, and I want to get this in our notes because it's going to come up a bunch in this chapter. So this will be our last thing for our notes today. Guys, please don't miss this, because you're going to see this word come up a bunch. So I'm going to just make a quick sketch of an exponential function that's decreasing. And my hope is that right now you're thinking, your pencil's right underneath your chair there. My hope is that when you see this that's decreasing, you're starting to think, I wonder what the equation for that would look like. What would be special about the equation for this graph? What do you know for a fact about B for this graph? Is it bigger than 1 or is it smaller than 1? Smaller than 1. We know that because when B is smaller than 1, we're decreasing, right? So sketch that on there and then draw yourself a little dashed line right underneath it. That line that your exponential function is getting closer and closer and closer to has a name. And I want you to get this in your notes. This is called an asymptote. ASYMPTOTE, asymptote. Usually we draw them dashed. It doesn't have to be, though. Technically, it's just a line. So these asymptotes are lines. They're not actually part of our graph, but it's sort of a line that our graph sort of folds along. And with exponential functions, the graph is going to get really, really close to the asymptote, but never actually touch it. Okay, you're going to learn about asymptotes a lot more in Algebra 2 and in pre-calculus and calculus. They become really important too. Okay, so reviewing what we know. I showed you guys what our little quiz was going to look like. If I gave you these 3 graphs and I gave you these 3 equations, do you think you'd be able to match up the graphs with the equations right now? Yeah. What are you going to look for to tell you which of these numbers goes with each of these graphs? Can somebody tell me what you're going to look for? Volunteer. We're going to look at B. We're going to look at the number here. And what's something special about that number that's going to help us know whether it's this one or this one or this one? If B is less than 1, what's going to be true about our graph? Is it going to be increasing or decreasing? If B is less than 1, it's going to be decreasing. And if B is bigger than 1, it's going to be increasing. How am I going to know the difference between A and B here? They're both increasing. How do I know that A goes with the 1.44 and B goes with the 2? What do you think? Not the start value. That's a good guess. What do you think, Aaron? Oh, did you guys hear that? Can you say it again a little bit louder? Did you guys hear that? Can you please stop talking and listen to this one more time? The bigger the number, the steeper the graph is going to be. So I know that B goes with the 2 because it's steeper, and 2 is bigger than 1.44, right? So the bigger number is going to go with the steeper graph. Number less than 1 is going to be decreasing. Any numbers greater than 1 are going to be increasing. We got that? You guys ready for this? All right, go ahead and close up your computers, please. And before I hand you our little exit ticket, let me go ahead and give you the assignment. So please put this on the back of your packet. Once you finish your little half sheet, folks, we're going to be working on today's assignment. Folks, this is not negotiable today. It is not okay for you to save this for when you get home or to do over the weekend. If you don't finish it, that's fine, but you must be working on this for the remainder of the period. I'm giving you a big chunk of time today, and I expect you to make good use of it, okay? So make sure you're working on this once you get done. But first thing I need you to do, close your computers up, please, is put your first and last name on this. When you get done, drop it in the tray over here, please. Yep. You're zoomed in all the way as far as it'll go. That's awesome. I want to see that in a second. Close it up for right now, but I want to see it once you're done with your little quiz.